Hi guys, this is going to be a reminder of why we can't add unlike denominators. So you might look at this problem, 1/2 plus 2/5, and think 1 plus 2 is 3, 2 plus 5 is 7, oh, it's 3/7. No, and this is why you can't do that. We're going to use these oranges as examples, okay? So 1/2, I'm going to take this orange and divide it in half, okay? So I'm going to take that orange and split it in half. So I have half the orange here and half the orange here, okay? So this is going to be half that orange. That stands for half. Now 2/5, we're going to take this orange and divide it into 5 pieces because that's what our denominator is. Here's the orange. We're going to divide it into 5 pieces. 1, 2, 3, 4, 5. All right. Do we see that? Let's see. Let's see if I can
lay them out.
1, 2, 3, 4, 5. And they're about equal pieces. We know that fractions have to be equal pieces. So 1, 2, 3, 4, 5 pieces, and I'm taking 2 of them. Okay, so that's 2/5. I took the whole, I split it into 5, and now I'm using 2 of them. All right, so now I have 1/2, half an orange plus 2/5 of an orange. I want to put them together because I'm adding. Okay, I put them together. Now, what do I call this? What do I call this? I don't have a name for this, which is why we need to rename our denominators so that we can know what to call our answer. So we're going to do that right now. Rename our denominators. We need to find the common denominator. Okay, so this should sound a little familiar to you, common denominator. To do that, I take my first denominator, my 2, and I list all the multiples of 2. Okay, so 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16. I could go on and on, but I'm going to stop there. Okay? And then I take my next denominator, 5, and I list multiples of 5. 5 times 1, 5. 5 times 2, 10. Well, before I even go any further, I can see that 10 is on both lists. I could keep going. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. I could keep going, but I already have a common denominator. Common means the same on both lists, right? So a number that's the same on my 2 multiples and 5 multiples is 10. So I can change 1/2 into tenths, and I can change 2/5 into tenths. I'm going to show you. So if I put this orange back together, all right, here's my whole orange again, right? And instead of splitting it into a half, I'm going to split it into tenths, okay? So I'm going to change my half into tenths. So instead of splitting it in half like that, you see I split it into 2 pieces, I'm going to split it into 10. 1, 8, 2, 9, 10. So now I split my orange into tenths, and that 1/2, that half an orange, okay, it's all in tenths. If I put it back together in my hands,
if that works.
So there's my whole orange. It was split into 10 pieces instead of half. If I take just that half part, just the half, how many tenths is that? Let's see, 1, 2, 3, 4, 5. So if I take just that half and change it into tenths, it's 5 tenths. And if I do it mathematically, if I don't have an orange to split up, then I say 2 changing into 5 was 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. So 2 times 5 is what got me 10. If I do something to the denominator and I want to make an equivalent fraction, I have to do the same thing times 5 times 5. So 1 times 5 is what will get me my new numerator. 1 times 5 is 5. So if I didn't have an orange, I could tell that 1/2 is equivalent to 5/10. I'm renaming that fraction, right? Now, if I take my 2/5, okay, if I put that orange back together, I had split it into 5 pieces, right? 1, 2, 3, 4, 5. But now I want to split it into tenths, okay? So I'm going to split all those pieces up into tenths. Okay, so now I have 10 pieces. If I go back to the 2/5, if I take those pieces that were 2/5 and see how many tenths there are, 1, 2, 3, 4 tenths. And that's because 5 times 1, 5 times 2. 5 times 2 is what got me to 10. If I did times 2 on the bottom, that's the same thing I need to do to my numerator. 2 times 2 is 4. So now, instead of 1/2 an orange plus 2/5 of an orange, I'm adding 5/10 of an orange plus 4/10 of an orange. And 5 and 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9. And now these pieces and these pieces are all the same size. So I know what to call them. I can call them tenths. My denominator stays the same. Hopefully that reminds you as to why we cannot add unlike denominators. Number 8. Number 8 is 3/4 plus 5/6. Okay, number 8 says 3/4 plus 5/6. Well, I have unlike denominators, so I need to make them like. So I'm going to list my multiples of 4 first. 4 times 1, 4. 4 times 2, 8. 4 times 3, 4 times 4. 4 times 5. 4 times 6. 4 times 7. I think I'm going to stop there. Hopefully I'll have a like one before the end. 6 multiples of 6. 6 times 1, 6 times 2. Oh, I already see that I have a common denominator. So I could keep going with my 6's, and actually I would get another one, but it's usually easier to use the smaller one, so I'm going to use 12 as my new denominator. Okay, so I'm going to say, I'm going to turn this fraction into 12ths and this fraction into 12ths. So I'm going to say, how many 12ths is 3/4? Well, 4 times 1, 2, 3 is 12. That's 4 times 3. So if I do times 3 up here, 3 times 3 is 9. So 3/4 is equivalent to 9/12. Okay, over here I'm changing 6 to 12ths. So 6 times 1, 2. 6 times 2 is 12. So if I do times 2 to the denominator, I need to do it to the numerator to make it an equivalent fraction. 5 times 2 is 10. So 5/6 is equivalent to 10/12. And now I'm adding 9/12 and 10/12, which I can add because they stay 12ths. And I end up as 19/12. And you might say, uh-oh, improper fraction. The numerator is bigger than the denominator. And the way you can solve that is division, but that's another video.